Carbon footprint measurement begins by understanding what happens inside a company's own operations. This is what we call Scope 1 emissions. Scope 1 refers to direct emissions generated from sources that the organization owns or controls. Typical examples include fuel burned in industrial boilers, diesel used by company vehicles, and emissions from on-site industrial processes. These emissions occur within the operational boundary of the company, which means the organization has direct influence over them. Before any company can seriously talk about decarbonization or climate targets, it must first answer a simple question. How much are we actually emitting? Measuring Scope 1 emissions is not just a single calculation. It is a structured process with 3 essential steps. First, organizations must identify all emission sources within their operations. Second, they must collect activity data, such as fuel consumption. Third, this activity data is converted into emissions using emission factors. In simple terms, the logic works like this. Activity data multiplied by an emission factor produces carbon emissions expressed in CO2 equivalent. This process transforms operational data, such as liters of diesel consumed, into a measurable climate impact. Scope 1 emissions are particularly important because they represent emissions the company directly controls. If an organization improves equipment efficiency, reduces fuel consumption, or electrifies its fleet, the emissions impact is immediate. Many of these emission sources are also linked to significant operational costs. Reducing fuel consumption often means lower emissions and lower operating expenses at the same time. That is why Scope 1 measurement is essential for both environmental management and financial management. It is also one of the first indicators reviewed in sustainability reporting frameworks such as GRI and in climate disclosures aligned with TCFD or regulations like CSRD and ESRS. In practice, many organizations struggle to measure Scope 1 emissions correctly. One common issue is underestimating emission sources. Companies often focus on large sources such as boilers or heavy machinery, but overlook smaller ones like backup generators, refrigerant leaks, or fuel used in remote facilities. Another frequent challenge is data fragmentation. Fuel consumption data may be scattered across procurement systems, maintenance logs, supplier invoices, and fleet management platforms. Without a clear process, this information becomes incomplete or inconsistent, and if the data is unreliable, the emissions calculation will also be unreliable. The first step in measuring Scope 1 emissions properly is defining operational boundaries. In other words, deciding which operations should be included in the emissions inventory. The GHG protocol, which is the global standard for greenhouse gas accounting, defines 2 main approaches. One is the financial control approach, where emissions are reported for operations under financial control. The other is the operational control approach, where emissions are included from operations the company manages operationally. The most important point is to apply the chosen approach consistently and document it clearly for transparency and auditing. Once operational boundaries are defined, the next step is collecting activity data. These are physical measurements of fuel consumption. Typical examples include liters of diesel, cubic meters of natural gas, or gallons of gasoline used by company assets. Ideally, organizations rely on direct measurements such as fuel meters or monitoring systems. However, in many companies, the data actually comes from fuel invoices, procurement systems, fleet management platforms, or operational records. The key challenge is consolidating these different sources into a single, consistent, and reliable database. The third step is converting activity data into emissions. This is done using emission factors. An emission factor indicates how much CO2 equivalent is generated for each unit of fuel consumed. For example, every liter of diesel burned produces a specific quantity of greenhouse gas emissions. These factors are usually published by organizations such as the IPCC, national environmental agencies, or energy authorities. The calculation itself is simple. Activity data multiplied by the emission factor equals emissions. However, it is critical to use credible factors and clearly document their source. Consider a practical example from the mining industry. In many mining operations, the largest share of Scope 1 emissions comes from diesel consumed by heavy equipment. Haul trucks, excavators, generators, and mobile machinery require large volumes of fuel to operate. These operations are often located in remote areas where multiple machines are operating simultaneously. Measuring scope. One emissions in this context requires collecting data from fleet management systems, fuel delivery records, maintenance logs, and operational reports, and consolidating all that information into a single emissions calculation. Now imagine translating that operational data into numbers. Suppose the site consumes diesel for heavy equipment and gasoline for light vehicles. Each type of fuel has its own emission factor. Emissions are therefore calculated separately for each fuel type and each category of equipment. First, emissions are calculated for each individual source. Then, all these results are aggregated to produce the total Scope 1 emissions for the organization. This structured approach ensures transparency and allows companies to understand which activities are driving their emissions. As organizations mature in their carbon management capabilities, the measurement process becomes more advanced. Emission sources are maintained in a structured inventory of assets that generate emissions. Activity data may be collected automatically through digital monitoring systems or integrated operational platforms. Instead of being calculated only once a year for reporting purposes, emissions become operational indicators that managers can track and analyze regularly. In mature organizations, Scope 1 emissions are fully integrated into operational management. Plant managers, fleet managers, and operations teams can see how their decisions affect emissions almost in real time. Improvements in efficiency, maintenance actions, or technology upgrades quickly appear in emissions indicators. When emissions data is connected with operational performance and cost indicators, decarbonization stops being just a reporting exercise. It becomes a real operational priority that guides everyday decisions.